I want to welcome everyone to our food industry office hours. I'm your moderator, Sam Alkin. I'm an associate professor in the Department of Food Science here at Cornell. This is the first week of classes for the fall semester, and I can feel the excitement for learning permeating through everything, almost like PFAS, which must be why so many of you registered for these office hours. There's a lot of interest in and concern about these per and polyfluoroalkyl substances and the implications of their levels in water, food, and for human health. And we've got a great set of presenters and panelists to help us better understand PFAS, the regulations being put in place, and how we should be addressing PFAS as food producers and consumers. So our panelists today are Dr. Natalie Capiro, who is an assistant professor in the Department of Biological and Environmental Engineering here at Cornell University. We've got Dr. Cheryl Murphy, who is a professor in the Department of Fisheries and Wildlife at Michigan State University and is the director of the Michigan State University Center for PFAS Research. We've got Dr. Jonathan Patali, who is a toxicologist with the New Hampshire Department of Environmental Sciences. We've got Conor Shea, who is a supervisor of the Pollution Prevention Unit at New York State Department of Environmental Conservation. And we've got Molly Tremblay, who is an environmental engineer in the Division of Materials Management for the New York State Department of Environmental Conservation. So great to have everybody here. For those of you who are tuning in to listen and ask questions, we will have an opportunity for that after the talks. You'll be able to answer or put in your questions. There's a little chat button at the bottom. If you press that, you can type in your question. You can either send it to me and I'll read it out to the group, or you can send it to everybody. So start thinking about those. I know a lot of you have already submitted some questions and we will get to those too. But now I'm going to hand it over to Natalie to kind of give us an overview of PFAS. Thank you, Natalie.
Okay, great. Thank you for the introduction. And glad to be here as part of this. So as I said, as it was said, I'm a assistant professor, but also brand new to Cornell, but actually also did my undergrad here. So it's a homecoming for me. So I've been doing a lot of PFAS work in the last, I say like about 5 years, and I'm here. I'm going to give you a kind of an introduction as to what exactly they are and a little bit about what we're doing in my lab to hopefully help resolve some of the issues. All right, so what are PFAS? What are they chemically? So they're synthetic chemicals, organic organofluoride chemicals, meaning they have the carbon-fluorine bond, and they have the moiety, the end group of 1 carbon and 2 fluorines. And as we know, they're found everywhere. They're ubiquitous, they're persistent, they're bioaccumulative, and they're toxic. The 2 most commonly, I say, well-known compounds are PFOS, the perfluorooctane sulfonic acid, which is in Scotchgard and Gore-Tex, and PFOA, perfluorooctanoic acid, which is also found in Teflon and many other consumer products. Here's some other additional examples of some products that are found in firefighting foams, food packaging, is why we're here, paints, pesticides, shampoos, photography, and just a number of products that are in our daily lives. In 2016, the EPA started to put in some health advisors, and they've adapted those since then, and we'll be talking about those, I think, in some of the later talks. So more about these ubiquitous. Well, about 200 million US residents, about a third of the population, live in an area that has drinking water that is contaminated by some form of PFAS. They're dubbed forever chemicals, which I don't like that name because part of my work is trying to break them down. Hopefully they are not lasting forever. But they came up with that name because they're really found in all of our bodies. I think 99% of people in industrialized countries, we have some of these chemicals in our body. They do bioaccumulate as we go through the food chain, and more people are looking into the health impacts of these compounds. And so it's like almost every other compound out there, there's developmental issues for unborn children. There's potential of many different types of cancers. And I don't think it's on here, but it also can impact the ability to develop immunity following a vaccine doses. So as we know, that can be something important depending on what's going on in society at the time. So most of the work that we have, or most of the information that we know about impacts on health are due to these epidemiological studies of the highly exposed populations, like people that worked at 3M, people that worked at DuPont. And if you see the movie Dark Waters, they'll also give you some information, a Hollywood movie, but it is very good. So these are the two compounds, PFOS and PFOA. You see the high concentrations of concentration found in people's blood, people working at 3M, people working at DuPont, and various other locations, other locations are around the country. But you can see compared to average blood donors, red cross blood donors are say down here, and then these workers are getting orders of magnitude higher concentrations. Okay, so where are these compounds found? Well, everywhere. I'd say these are just the detections. So the light blue are drinking water sources. And so the darker blue, the purple are the military bases. Why military bases? I'll tell you a little bit about that. And that's an area of my work in just a little bit. And then some other known locations. So we do have, but first of all, I also want to mention, so a lot of my funding comes from the Department of Defense, and to claim the military bases, they're estimating over $2 billion. And I'm sure that is way low, actually. And then, so as you would expect, proximity to these sources of PFAS is really associated with impacts on population. So now taking a little zoomed in area of the in the Northeast, you don't see many in New York. I'm guessing that's not solely because it's clean. I'm guessing there hasn't been as many measurements, and I know that's an ongoing area of work. New Jersey, there's a number of spots because New Jersey has been one of the states that has been actively putting in health advisories prior to the federal government. And then there's also in New Hampshire, there's some larger numbers of detections. So a little bit more about what is PFAS. Well, if you didn't know, it's not just one compound, it's a class of compounds that are probably over 5,000 compounds. Many of them are trade secrets. DuPont does not want to release that information. 3M does not want to release information, which makes it very difficult to do any kind of studies. So within these class of compounds, there are different categories. And just to give you a little bit of terminology. So depending on the chemistry, depending on whether it has carboxylic acids or sulfonic acids, the PFCAs, PFSAs, phosphinic acids. And these are, again, some of those compounds that are the most well-known, PFOA, PFOS, and then Gen X is the new replacement that seems to be causing just as much trouble. And then, so these are perfluoric alkyl acids. These are the compounds that are typically found in the environment. To get those, sometimes there are what we have PFA precursors, so compounds that were made for other sources, then break down to these perfluoric alkyl acids or PFAAs. And those are based on their chemistry, fluorotetramer-based chemistry or electrochemical-based chemistry. And these compounds then are broken down to form those PFOS and PFOA compounds. There are other compounds that are also PFAS, such as PTFE, Teflon, the compounds like that. Just obviously a large number of compounds out there. And those are those perfluoroalkyl acids precursors that we actually done a lot of work on. We've seen some transformation on some microbial transformation, which is my area of work. So it's kind of interesting. I've seen with PFAS, there's just a lot of attention drawn on PFAS. So I'd say much more than other compounds. Part of it is because of the toxicity, potential toxicity, persistence, bioaccumulative capacity. And there just seems to be a lot more public awareness than I've encountered with other contaminants that I've worked with during my career. And another thing that's been interesting is the analytical capability. So the analytical capability has really ramped up in the last, let's say, decade, and more labs have that capability. Of course, it is very, very expensive to do this analysis. So that is also a limiting factor. But I just want to point out, I've been doing groundwater remediation work for, I don't know, 15 plus years. And if you look at our history with other contaminants, I really think it's just the beginning of the work, just because there's so much, it's so much more complex. There's so many chemicals that this is really going to be an area that we're going to continue to work on for decades. So we have made some progress. There has been some remediation options that we've determined that are not viable. The ones that are in the lower corners here, this is for water, and then it's for soils. And then the upper right, we're seeing some potential. Of course, how the technology behaves with PFAS is really dependent on which compound you're talking about. The length of the molecular weight of that compound. But we have had some success. So this is definitely work that continues to go on. But cost does obviously need to take into consideration. But we're pulling back on some of our historic techniques that we've tried, like activated carbon, which is basically a Brita filter as a way to adsorb these compounds, trying to remove it, not necessarily breaking it down, but removing it from our water. And then just a couple slides on what I work on specifically. As I said, my funding is mostly from Department of Defense. So I work on these aqueous form filling foams, which are used to put out fuel-based fires that happen when like a plane crashes. This mock-up plane here is intentionally placed on fire, and then there are fire training exercises. So there was a high concentration of PFAS here. So we've seen transformation of these PFAS compounds in the environment from what is initially sprayed to what is detected, but we're not sure how exactly that happens. And that's really what our work is focusing on. So we don't know how these compounds transport in the environment. We don't know how they're broken down, but there's some evidence that it does happen. We don't know which microbes are involved. We don't know whether it happens in the presence of air or an aerobic process or in the absence of air, an anaerobic process. So this is some work that we're doing. And I just want to give you one example of one compounds that we're looking at, 8,2-FTOH or fluorotellular alcohol. And this has been shown to break down to PFOA. It's present in a number of these formulations that are used at military bases and other airports. And it's also a part of a byproduct of the chemistry, the production process. So previous studies have shown that microbes are able to break down these compounds under aerobic conditions. So in the presence of oxygen, using microbes from a number of different sources, but not from where they're actually sprayed. So that's the AFFF, aqueous form filling foam. So we took microbes from that site, and we thought these guys have been exposed to these chemicals for decades. They're probably most likely going to break it down, if anyone can. And then we also use a number of really expensive, but also highly sensitive techniques to measure these compounds. And we have targeted, meaning we have a standard, we know what it is, and then non-targeted, where we evaluate what it is based on its molecular weight. And this is images from actually my collaborator at Brown University. And what we do is we see trends over time, and then we see these increases, and we believe that that's a transformation product. So we are getting transformation of the compound that we introduced. So this is the simplest form of my studies, is these little bottles. We put soil in it, we put groundwater in it, we add the contaminant, and then we look at under conditions of aerobics, on the presence of oxygen out here on the right, and then different conditions based on the elements that are available, based on the resources that are available, otherwise known as redox conditions. And going to go through just kind of like the summary, and just to show you that this is pretty complicated. This is one compound. So under aerobic, nitrate, sulfate, iron, methanogenic conditions, it breaks down, goes down a couple steps, and then it starts to bifurcate off depending on the availability of oxygen. And we get a number of different byproducts are being formed, but you do see PFOA as one of the byproducts. So also, I'll mention at the end, though, that these papers are published. If you'd like to get more information, I'm happy to send you the articles. So we've made some progress, but there's still a lot of work to do. On the federal government side, they are starting to think about having drinking water standards or MCLs, but we're not quite there yet. But we do have some evidence that some of these compounds, at least the precursors, are either amendable to breakdown. Either maybe we want to encourage that, or maybe we want to limit that depending on our objectives by native microbial populations. but that transformation seems to depend on what microbes are available or present and the condition, whether the oxygen is present or not. So it's a really interesting problem. Unfortunately, it's also a pretty complicated problem. And as I said, I think we have quite a bit more work to do. So it's my funding source I want to acknowledge. SERDP is the acronym Strategic Environmental Research and Development Program. The DoD is the main contributor. And those are the resources, the couple articles that Microbe has published to date. So thank you for your time. And I look forward to the rest of the session.
Thank you, Natalie. I always love seeing microbes as a microbiologist, right? As good components and bad components in these systems. So we'll see how it goes. I will ask one quick question before going on to Connor that popped up in the chat box. That came from Dan, is talking about, the toxicity of the chemicals. Some exhibit low toxicity, some are high. Where does PFAS kind of fall on that spectrum of toxicity? Is it more concerning with acute toxicity, or is it chronic that will develop, diseases over time?
I don't know if we can say that because there are 5,000 chemicals. So I'm sure some fall into each category. Without the official regulations in place, it's maybe hard to get some of that funding to do all those toxicity studies that are needed. And what people are trying to, because there are 5,000 chemicals, not just for toxicity, but also transformation and movement in the environment, we're trying to group the contaminants into categories based on their similar characteristics, because we can't possibly analyze 5,000 or look at 5,000 compounds individually. And they're usually in mixtures anyways. So like maybe this class of compounds we're anticipating won't be that detrimental, or will transport, or won't transport, or the microbes can break this down or won't break this down. So we're trying to cluster it like that because there's way too many chemicals. And I'm sure there are more that we're not being told about.
Right.
Unfortunately. I mean, because that number has continued to increase over the last few years I've been doing this work.
Yeah. Well, that just highlights all the work that's needed in this space, right? To really put around this. Great. Well, then here we'll pass it over, Connor, if you're there. And
yep, I'm here. I'm gonna share my screen, or attempt to. Let's see. Let's see if this works. Can you see that okay?
Yeah, right now we see your slides, and so if you hit presenter, if you hit from beginning, we should be good.
All right, let's see here. From beginning. Oops, that looks like the end. There we go.
There you go. Perfect.
All right, let me just get started here. So this is actually based on a presentation that we had shared in advance of the hazardous, the PFAS and food packaging law going into effect. So it went into effect December 31st, 2022. But, it's kind of been adapted for these purposes today. In any case, just wanted to share a thank you for having me join today. This is an important topic to get the word out on, and, thank you for the introduction before. So I'm just going to kind of jump right into the presentation here. Hopefully my controls work out okay. They don't seem to be working so far. Oh, here we go. Just need to click the mouse pad here. All right, so we already kind of covered this. Natalie did a great job at covering the toxicity and sort of the breadth of uses of PFAS substances. So I'm going to kind of gloss over this part and get into more of the context of our law here. So, one thing I did want to kind of touch on before getting into the law, though, was, this graphic that was put together by one of the NGOs that works in this space, just showing how PFAS can move through the environment, starting with food packaging. On the left-hand side, you see any contaminated food packaging being tossed away into a landfill, and then from the landfill, through leachate or other means, making its way out into the environment. And then, the right-hand side of this diagram kind of shows how any sort of contaminated food packaging could contribute some PFAS to the food that it's containing, and then you as the consumer could end up consuming PFAS that have been imparted from the food packaging onto the food that you're eating. So that's, kind of an important pathway for us all to think about here as we go into the discussion on the law itself and what it does and, the reason for this law. So, just given the persistence of PFAS compounds in the environment and their links to a whole slew of different negative health impacts, one of the important ways to remove PFAS from the environment and from human bodies is to stop it right at the source through placing restrictions on PFAS and various consumer products, one important one being PFAS in food packaging. So just to give a little bit of a historical context of the law, the PFAS and food packaging law, it's part of the Hazardous Packaging Act. So the Hazardous Packaging Act was enacted back in 1990 to address some issues related to the presence of 4 different toxic heavy metals in packaging materials. So those metals were lead, cadmium, hexavalent chromium, and mercury. So at the time when that law went into effect, these toxic heavy metals were found in some packaging materials at pretty high levels. And as a result, there was some potential for them to leach out of packaging materials and into the landfill, landfill wastewaters, and make its way out into the environment. So when the law fully went into effect, I believe it went into full effect 1994, it restricted the total levels of these 4 heavy metals in packaging and components to 100 parts per million. So, given the fact that packaging makes up a pretty significant portion of our municipal solid waste, EPA estimates it's over a quarter of our municipal solid waste. The potential for reductions of these toxic metals in the environment was pretty significant. So, fast forward to 2020, the legislature in 2020 voted to amend the Hazardous Packaging Act to also restrict the presence of PFAS in food packaging. And we'll get into how some of these terms here are defined as we get into some of the other slides, but this is one of the key statements in the law that I have shown here. So effective December 31st, 2022, no person shall sell, distribute, or offer for sale in the state food packaging containing PFAS substances as intentionally added chemicals. So it's important to kind of highlight right here that the original law applied to manufacturers and distributors, whereas the PFAS and food packaging amendment applies to persons, which is why I highlighted that. So that can be anyone from a food truck operator to a grocery store to a manufacturer or a distributor that's selling food packaging or food products that are in such packaging. It's also worth noting before I move on that the department has been implementing the Hazardous Packaging Act, including this amendment, without a rulemaking, that is, without developing any regulations to implement it. So just implementing it as written and posting some guidance materials on our webpage. So now just wanted to get into a couple other recent actions in addition to the PFAS and food packaging law. Some of the ways that New York is trying to keep PFAS out of the environment by implementing restrictions on its presence in consumer products. So we're going to get into the Hazardous Packaging Act in a bit more detail as we go through the slides, but we also have a newly enacted prohibition on PFAS in apparel. So this was signed into law earlier this year. It goes into effect January 1st, 2025. So this not only includes restrictions on the sale of apparel containing PFAS, but Included in that is outdoor apparel, and notably outdoor apparel for severe wet conditions where it is often treated with PFAS to provide that water repellency that we often see people using PFAS for. And another law that was enacted in the most recent session, the Carpet Extended Producer Responsibility Law. So this is a law that's going to require the establishment of a carpet recycling program. It also includes a provision that restricts the sale of carpet with intentionally added PFAS that will go into effect in 2026. Okay, so just wanted to share those couple other sort of related bits of legislation that have some relevance to today's conversation. But getting back to PFAS in food packaging and the law and how some of the terms are defined, these are pretty important for everybody to understand, in the context of the law and your obligations under it. So the term package, so this was something that was originally defined in the original Hazardous Packaging Act. So package means a container that provides a means of marketing, protecting, or handling a product, and shall include unit package, intermediate package, and even a shipping container. So, just sort of your general definition of a package. This term also includes, but is not limited to, any unsealed receptacles such as carrying cases, crates, cups, pails, rigid foil, and other trays, wrappers, wrapping films, bags, and tubs. So those were all kind of the different types of packages that were envisioned as being included under the original Hazardous Packaging Act. Then under the amended language, the PFAS and Food Packaging Amendment, the term food packaging was added. So there is now a definition for that under the amendment. So food packaging means a package or a packaging component that is intended for direct food contact. That's a very important aspect of this definition. And it's comprised in substantial part of paper, paperboard, or other materials originally derived from plant fibers. So that's a pretty key distinction here, that it's originally derived from plant fibers. So generally, anything that you would call basically paper packaging, cardboard packaging, paperboard packaging, those types of materials, when you think of those are the types of packaging that would be included in that definition. Okay, let's see here. So just wanted to share some common examples. So this is not by any means an exhaustive list of examples of types of food packaging where PFAS could be intentionally added, but these are just some pretty common examples. So couple things in the fast food world, sandwich wrappers or burger wrappers, they sometimes come in like a piece of wax paper, so that type of thing, wax paper, or like a sleeve that would contain the sandwich or burger, things along those lines would all be some good examples of food packaging that may contain intentionally added PFAS. Restaurant takeout boxes, including pizza boxes. So those corrugated cardboard type containers, used to serve up pizza. Hot and cold beverage containers. So think of, your coffee cups, your soda cups. Those in a lot of cases are paper products that could have PFAS added as sort of a leak-proofing, waterproofing agent. That's not to say that in all cases those waterproofers are PFAS-based, but these are some common examples. Takeout bowls with lids, those takeout soup bowls you might get from a deli made out of paper, paperboard. A good example of sort of a food product that has food packaging as part of the product. Microwave popcorn bags, it's a good example, and that's one where PFAS have been found. A couple studies have found PFAS to be used in microwave popcorn bags. And another common example, packaging that's used for baked goods. So if you go to a bakery, you might get some treats that come in sort of like a white cardboard box. You know, they want that to be kind of grease proof due to the amount of butter that's often used in baked goods, or in some cases you might have it handed to you in sort of like a waxed paper sleeve. So those are, again, some common examples here. So now just to get back to the definitions that are used in the law. So the term intentionally added, that's an important one to define here. So that means a chemical in a product that serves an intended function in the product. So as I kind of mentioned before, PFAS is generally added to food packaging with an intended function in mind. So that intended function is to serve as a waterproofer, leak proofer, grease proofer. So you might see food packaging type products marketed with those terms included in the marketing materials. So you might see, you know, hot and cold paper cup, leak proof, waterproof, you know, you might see those types of characteristics being applied in the marketing materials. So those are good indicators that, you know, some sort of lining material has been intentionally added, and in some cases it may be PFAS. And then lastly, for the important definitions, the term PFAS itself. So our law uses somewhat of a broad definition. So PFAS under our law means a class of fluorinated organic chemicals containing at least one fully fluorinated carbon atom. So, you know, this could include anything from those long chain PFAS, like PFOA, PFOS, where you have 8 carbons and they're fully fluorinated. Or it could include something as small as a, you know, 1 or 2 carbon chain that's fully fluorinated. So it includes a wide range of different compounds. By some estimates, this could be over 9,000 different substances that are included in this class based on this definition. So now just to go back to some of the language that's in the law. I know this is a pretty text-heavy slide, but this is some important information to cover on certifications of compliance. So in the original Hazardous Packaging Act language, the restrictions on selling packaging containing those heavy metals were placed on the manufacturers and distributors of the packaging. So the law included a provision allowing manufacturers and distributors of packaging to rely on a written statement or a certification of compliance from the manufacturer or the manufacturer of the packaging or packaging components saying that it complies with the law. So manufacturers and distributors could essentially go one level up the supply chain to confirm compliance rather than doing their own independent laboratory testing to measure the levels of those metals. So now when the law was amended, the entity subject to the restriction became persons selling food packaging and not just manufacturers or distributors. So this was kind of a shift in the language, but you know, the department is allowing persons selling or offering food packaging for sale to rely on certifications of compliance provided and signed by the manufacturer or distributor as well. So you know, it's sort of a provision in the law that's being a little bit more broadly applied here. Okay, so again, as I mentioned before, this presentation was based on one that was originally given in the lead up to the effective date of the law. So, you know, these these actions still do apply, but they should have been taken by this point, in preparation for that December 31st deadline. So any food packaging manufacturers really before December 31st, 2022 should have already stopped adding PFAS to the food packaging that they are offering for sale in New York. Any suppliers or distributors of food packaging should have been in contact with manufacturers to ensure that no PFAS was being intentionally added in the products that they were offering for sale. And in some cases, if you didn't already have that assurance, we were suggesting that you obtain a certificate of compliance from the manufacturer. And then for any retailers, so any restaurants, grocery stores, etc., anybody selling food packaging or food products in packaging that meets the definition of food packaging, it was recommended that you contact the suppliers and distributors to make sure you're not purchasing food packaging with intentionally added PFAS and obtaining those certificates of compliance. So now, just a couple notes on safer, compliant alternatives. So there are a number of alternatives available, and these have been available for quite a number of years for anyone who sells food in food packaging or that is in the business of selling and distributing food packaging itself. So aluminum containers, these have the benefit of being infinitely recyclable once they're cleaned. So those are a good option and have always been. Clay-lined paper containers. So there are some sort of clay-based materials that have been used to line food packaging, and these serve as waterproofing and leak-proofing agents. And these, to my knowledge, do not contain PFAS. PLA, so that's polylactic acid. So that's a sort of a natural bio-based type of plastic, or other materials considered plastics have been used to line containers to provide that leak proofing, grease proofing, waterproofing. There's also some products out there called densified paper products. So it's sort of like a compressed paper type of material that essentially what it does is reduces the pore space in between the paper particles in a product, and reduces the ability of water or grease to leak through. In addition to that, you have compostable plastic containers, made out of various bio-based plastics that can be sent off to the commercial, industrial types of composting facilities. And then lastly, durable, reusable containers, if those work with your sort of configuration at your outlet. So those were sort of the main points that I had to get across on PFAS and food packaging and the law, who it applies to and how. So just want to thank you again for your time and attention here today. And I'm going to stop sharing my screen.
Great. Thanks, Conor. No, that was very informative on the regulation.